Hello, welcome to our channel, Knowledge Spread by Sir Boots, your teacher in General Mathematics. Please like, subscribe, share, and hit the notification bell. Let's begin! In this video, we will discuss the second part of the presentation about the attributes of the rational function. We recall that the function we discussed in the first part was f of x equals 3x over x plus 3. And our vertical asymptote is x equals negative 3. And our horizontal asymptote is y equals 3. Now we are going to get the x-intercept of the rational function. To get the x-intercept of the rational function, we are going to equate the numerator by 0. Equate the numerator to 0. So x-intercept. And we equate the numerator to 0. And so x equals 0 is the x-intercept. So x-intercept is x equals 0. Why? Because in x-intercept, y equals 0. And if the numerator is 0, in the fraction x plus 3, then the value of y will be equal to 0. That's why we equate the numerator to 0 to get the value of the x-intercept. The point on which the x-intercept is located is 0, 0. And to get the y-intercept, of the function f of x equals 3x over x plus 3, we have to set y, we set x to 0. We set x to 0. And so, we plug in 0 to the function. Now we have f of x or y equals 3 times 0 over 0 plus 3 is equals to 0 over 3, and that is equal to 0. So our y-intercept also, is also 0. And the point on which the y-intercept is located is also 0, 0. 0, 0 is origin. No, so that is the origin. So now we already get the vertical asymptote. Now we will collect the vertical asymptote. Here VA vertical asymptote is x. No? X is equals to negative 3, and the horizontal asymptote h sub a is y is equals to 3, and our x-intercept is x-intercept is x is equals to 0, and our y-intercept is y is equals to 0. This is important because it is necessary in the graphing, so that we will know the behavior of the graph as it approaches the vertical asymptote. So now, to know the behavior of the graph, we're going first to construct interval. So our interval is found by constructing on the number line. At the end of the number line, at the left is the arrow, that is negative infinity, and in the right also positive infinity, no? And this is infinity. So negative infinity, and here is positive infinity, and this is negative 3. That is our vertical asymptote. So from negative infinity to negative 3 excluded, that is our first interval, and our second interval is from negative 3 to positive infinity. Okay, so these are our intervals, and we will get the test value. The test value is from negative 3, we move to the left. We will not include the negative 3 because that's understood. If you will use the negative 3, the fraction will be undefined. So move a little bit to the left, that is negative 4. And also here the test value is x. Move a little bit to the right, x equals negative 2. So after that, we will make a table of signs. The table of signs, this is how to make the table of signs. No, table of signs on and the intervals will be from negative infinity to negative 3. That is the interval. And from negative 3 to positive infinity. Okay, so the test value is x equals negative 4, and here x is equals to negative 2. Okay, so the numerator is 3x, and the denominator is x plus 3. So we plug in the value of x, that is our test value, to x in the numerator. So if x is negative 4, so 3 times negative 4 is negative 12, and so the sign is negative. And if x is negative 2, so 3 times negative 2 is negative 6, so the sign is negative still. And we'll go to the denominator. If x is negative 4 here, so negative 4 plus 3 is negative 1, so the sign is negative. And if x is negative 2, Negative 2 plus 3, the sign is positive. Okay. So, the quotient of sign is negative divided by negative equals positive. And negative divided by positive is negative. This simply means that for positive value of function, the graph is located above the x-axis, and for negative, the graph is located in the below the x-axis. So we will graph. No, we will graph. We'll have another. Here I will graph. Here. So let's make a Cartesian plane. Cartesian plane. And that is x, this is y. So x, y. The vertical asymptote is VA equals x, is x equals negative 3, no, x equals negative 3, and the HA or horizontal asymptote is y is equals to 3. Okay. H horizontal asymptote is y equals 3. So we'll plot that. So from here, 1, 2, 3, going to the left, so that is negative 1, negative 2, negative 3. So it is the vertical asymptote. So negative 3. Negative 3. Okay. So it is excluded. Wait. It is excluded. Like that. And also, the Y-intercept is 3. So 1, 2, 3. So this is the Y-intercept. The horizontal asymptote, I mean. So this is VA, and this is HA. The Y-intercept and X-intercept passes through the origin. Again, in the interval, x, interval negative infinity to negative 3, the sign is, the quotient of sign is positive, so it's going up, so it's here. It's here. So going up. So that is the graph. And this is the behavior of the graph here is as x approaches, no? As x approaches negative 3 from the left, then y increases without bounds. So that is the notation. Okay. In the interval, in the interval -3 to infinity. So like that, the sign is negative, so it's going down. Okay, the x will be from a little bit closer to the horizontal asymptote, like that. It passes through the x-intercept and y-intercept, going there. Okay, so the behavior of the graph is that as x approaches -3 from the right, y decreases without bounds. So we have obtained the x-intercept and y-intercept in this video. Also, we have also obtained the behavior of the graph. So this is all for this video. Good evening and see you next presentation.